Hello, my name is Elijah Porter. We'll begin today's work with a probability problem. I'll begin by reading the problem to us. A spinner has four equally likely regions, numbered 1, 2, 3, and 4. The spinner also contains two equally likely colors, red and yellow. The arrow is spun twice. We need to draw a tree diagram identifying and displaying all the possible possibilities. And then the question that we need to answer is, what is the probability that the spinner will land on the number 1 on the first spin and then on the color red after the second spin? We'll begin the process by identifying our tree diagram. Now, a tree diagram is very good because it has several different branches. What we're going to do is begin with the first event. Now, what is the event in this case? Well, an event is an action, a physical action that comes into play. And we're going to be spinning this spinner twice. So our action is the actual spinning of the spinner. So in event 1, what we have here is we need to identify with the branches how many options are available on this particular action. Well, it says here that we're going to be spinning the spinner first to get a number 1. But based upon the problem, there are 4 equally likely opportunities, which means we have the first equally likely scenario would be the number 1. The second equally likely scenario would be the number 2. Then we have the number 3, and then we have it could land on the number 4. The reason why equally likely is important here is because it lets us know what the probability is. If I have 4 equally possible opportunities, then that means that the probability of getting a 1 is 1 out of 4. The likelihood of spinning a 2, if they're equally likely, is 1 out of 4. And likewise for 3, 1 out of 4. And lastly, 1 out of 4. That's the reason why the equally likely nomenclature is important. It tells us how to identify the probabilities or the ratios. Then after that scenario, we have to identify what happens on the second event. The second event is the spinning of the spinner for the color. And we have that for each of these opportunities. That way, it doesn't matter which number we get. We know we still have to spin it a second time. So this is event number 2, which is spinning of the colors. And there are 2 equally likely colors, red and yellow, which then means we have to make sure that we represent this. Equally likely colors, red and yellow. Equally likely, red and yellow. 1 branch for each color. Equally likely, red and yellow. And lastly, in case we spin a 4, equally likely colors are red and yellow. And so what happens is we extend, make sure our tree extends to the next set of events, and we identify what is the probability of getting a red. Well, it's equally likely. So it's 1 color red out of 2 possible colors. Chances for yellow, 1 possible yellow out of 2 possible colors. Same here. 1 out of 2 for that red, 1 out of 2 for this yellow. And likewise for the remaining branches. 1 out of 2, 1 out of 2, 1 out of 2, and lastly 1 out of 2. So now what we need to figure out is, based upon our completed tree diagram now, what is the likelihood or the chances that we'll get a 1 on the first spin and then a red on the second? And so what I will do is I will trace, here's our 1 branch, and it goes through, and then we're on the red branch now. So the black trail identifies the trail of information that we need to answer this particular problem or this particular question. And what we're going to do is, when you have subsequent or sequential events, you always have to multiply your probabilities. So we're going to end up with 1/4 times 1/8. Times 1/2. This is the probability of getting a 1 on the first spin. This is the probability of getting a red on the second spin. Multiplying those fractions gives us 1/8, 1 out of 8 possibilities. Now, that's how this is solved numerically. But the value of the tree diagram is it allows you to notice your answer visually. So let's check. If this is the one path that we want, how many total paths are possible? Well, not only could I get a 1 on the first spin and then a red on the second, I could also get a 1 on the first spin and then a yellow. Or I could get a 2 on the first spin and then a red on the second. Or I could get a 2 on the first spin and then a yellow. Or I could get a 3 on the first spin and then a red. Or a 3 on the first spin and then a yellow. And lastly, it's important to understand we could also get a 4 on the first spin and then a red on the second or a yellow. For a total of 1, 2, 3, 4, 5, 6, 7, 8. 8 possible options, but we're only interested in the one branch. The one branch. So out of the possible 8 variations, we're only interested in the one that qualifies for a 1 on the first spin and a red on the second. So when you're dealing with probabilities, it is very important to have multiple representations and to also interpret them and then to confirm as a check and balance that your math is correct. Thank you for your time, and we'll look forward to another series.